We can think about line symmetry as the number of ways that we could fold a shape exactly in half on itself. Here we have an equilateral triangle, and if I want to draw the lines of symmetry, I would say there's one here going from the top corner halfway through the bottom edge. There's another one then going through the left corner and then halfway through the edge on the right, and finally another one here. And interestingly enough, with a triangle or with an equilateral triangle like this, all of the lines of symmetry meet exactly in the center, or along the medians of the triangle, as we'd say. So that's an example of lines of symmetry. If we have a look at this rectangle, how many lines of symmetry does it have? Well, we could fold it in half vertically, like this, and you could also fold it in half horizontally. A lot of people would then say you've got a line of symmetry going from one diagonal to the other, but you actually don't, because if we folded that in half, you would end up with something which looks like, see if I can draw this. Yeah, you would end up with something which looks a bit like this. You wouldn't end up folding the shape exactly in half. So a rectangle has only two lines of symmetry, vertical and horizontal. Have a quick go at these questions. See if you can work out how many lines of symmetry each of these shapes have. Pause the video now and have a go, and when you're ready for the answers, press play. Okay, so we should notice an isosceles triangle has only one line of symmetry, and we could draw that here with a dotted line, like that. So through the top corner, down halfway along the edge at the bottom. A regular pentagon has 5, and you could draw them in like this. So again, through the corners and the midpoints of the edges. And then lastly, the parallelogram doesn't actually have any. There's no way that you could fold this in half exactly onto itself.